Okay, so this is my third time trying this, so hopefully I'll get it more or less correct this time. So here's the deal. Open up the syntax for the diffusion of innovation or the adoption of innovation data. Open up that syntax and get R open. And then what you should do is go ahead and run the stuff at the top. And I updated that syntax, so you should use the version that you can get off of Dropbox. So anyways, you'd enter this stuff in up here. So if we copy this stuff, right, what that's going to do is going to remove everything that used to be there. It's going to attach this file, or it's going to read the file in, it's going to attach it, it's going to ask for a summary of it, and then we're going to run library on car so that we will be able to use the recode function. So if I copy that and paste it in, and I run it, bump it a bomb, there it goes. All right, and so it already is loaded car, so it isn't doing anything special about that. So here we are. So oh yeah, so what it did when we said remove all, it got rid of everything else, and then we've attached this new stuff and we have a summary of it. So there we go. We have our data in there. And then the first thing that's done here in this syntax is there's a whole bunch of variables that are created. And I'm going to run that. Okay, and you can see that we didn't get any errors. We just ran it, and then we got some results here that were printed out into our text kind of, or I guess our command line window. And so yeah, so the red here, okay, it worked. And what we did is we took the log transformation of a bunch of variables, and you can look at this first one here. And all this says is that what we're going to do is we're going to make a new variable called all edits pre ln, which means this is the count of all edits that people made prior to the observation period for the study. And then what we're going to do is we're going to take the log of that original variable plus 1. And the reason we do that is we don't want to take the log of 0. So the smallest value any count could be is 0. And if you take the log of 0, you get an error because it doesn't make sense. And so anyways, it's done the same transformation for all these variables. And it's also done the inverse transformation of some of these variables. And the inverse transformation was used in our previous research, and I don't like it very much. And so what I'm doing here is I'm making, for a subset of variables that we actually used in the analysis, the inverse transformation of those variables, and then I'm going to compare those to the log transformation of them. And we're also going to compare that to the original untransformed variable to see why it is that we wanted to transform them in the first place. And here's a bunch of things I made earlier, so I'm going to go ahead and get those out of the way. Okay, so over here, let's see, I've added in a little bit of new syntax here, so make sure you're using the current version of this syntax. And so originally, had these two sections here, one that's listing histogram commands for the inverse transformation of the variables that we used, and the other one is for the log transformation of those variables. And then what I thought would be more informative is to be able to compare item by item the original value, the inverse transformation, and then the log value. So that's what we have right here. Here is active months, so the number of months that people were active prior to the observation period for the study. And we're going to make a histogram that's yellow out of those, and then we're going to make one that's orange out of the inverse transformation of that same variable. It's the same data, it's just been transformed. And then here is the log transformation histogram of that same data. And what we're going to do is we're going to make 3 columns and 3 rows. So our first set, we're going to look at 3 different versions of active months, and then we're going to look at 3 different versions of the number of content edits, and then let's see, this next one is saying content edit again, so it actually should be doing something different right there. So you might want to change that. Really, content, oh no, content edits pre, which is before the observation period, and then content edits during the period of the observation, right? So it's just a 28-day slice. So this one is going to be a bigger set of values than this one. So this one's more like total edits beforehand, and this is edits during the observation period. Okay, cool. So sorry I got that wrong for a second. All right, so we're almost done with this video. So here we go. First thing we're going to do is going to tell it to arrange our images in a certain pattern. And then here we are, we're going to run the first three. Copy, put this in here, enter. And there they are. And we're going to go ahead and do the next two sets of three, like this. And then we're going to look at our results. Okay, so what we can see right here is on the first row we have all yellow, right? Which means that these are all the raw variables. And we can see for active months, most people were active for, say, 25 months or fewer for about 2 years, right? But then there were a few people that were active a lot more. Okay, so it's definitely a skewed variable. But it's not nearly as skewed as the total number of edits that people had made beforehand. Most of the people here are making some small amount less than, say, 5 or a few hundred, but then there's a few people who are over 30,000. And then here in the content edits during the period, so during a single month, most of the people are here in the kind of low hundreds, but we have someone making 8,000 at least. So we have some outliers for sure. Okay, and then we can see that the inverse transformation has changed the kind of arrangement, and it's actually kind of ended up flipping the distribution sort of, and it's not that handy, I don't think, and you can look and see how it's calculated, which is right up here. And so let's see, it's -1 times 1 over 1 plus the value, right? And then I'm adding a 1 in there to avoid zeros. So basically what this is it's made a ratio 1 over however big that number was, and then it's multiplied it by -1, so it's flipped it around. Now, a problem with that is that, so this is going to range, as you can see, actually, between 0 and 1, and it's going to stack up a bunch of values, all the big values near the top, up near 1, because basically they're going almost to 0. 1 over a giant number is almost 0, but it's being flipped around. So they're still in the same order they would be, but they've been kind of compressed at the high end of the scale. Which I don't think is what we want, because these are weird looking distributions. And in contrast, the log transformation is looking a little bit, at least more like a normal distribution, although with a pile of people here at the kind of low end, people that are doing very little activity. So anyways, you don't want your distribution to be looking so different from something that's sort of kind of normal, and it looks to me like the log transformation is doing the best job of that out of these. So anyways, what you should do is open up the syntax and run it, and then come on down here, and you can notice that there are 4 more variables, right, for the inverse and for the log. And so what I want you to do is get these ones here arranged like these ones are, in order to look for these other variables to see if they also show the same story about the effects of the different transformations. So anyways, that is your task.